to dig deeper into the downstream sector of the oil and gas industry, specifically the refining and petrochemical operations, with our special guest for tonight, Dr. Wael Hamd. So Dr. Hamd obtained his master's degree in 2006 from Claude Bernard University in the catalytic domain. And in 2009, he obtained his PhD in process and chemical engineering from NC School of Engineering. And between 2010 and 2014, he worked as a researcher in Paris 6, Paris 7, and the American University of Beirut, where he has done several researches related to the hydrogen production and petrochemical industry. And also he managed to participate and organize several conferences related to the energy and the oil and gas sector. And finally, he's a professor at the Lebanese University and the Lebanese American University in the petroleum and petrochemical departments, where he's responsible for the downstream related courses in the universities. Now, I shall leave the floor for Dr. Wael to start his presentation. And if you have any questions, please write them down or unmute toward the end of the session in the Q&A. Dr. Wael, you can start if you're ready.
Okay, hello everyone. Thank you, Hassan, for the invitation. I'm very happy to be with you tonight to give you an overview about the petroleum refining processes and some petrochemical operations in the oil and gas sector. So I start by my outline. At the beginning, we start a short introduction about the oil and gas value chain. Then I move to petroleum refining processes and petrochemical industry. And I finish my presentation by a specific case about the how to transform natural gas in Lebanon to petrochemical products. So as you know, the oil and gas value chain, we have different part in the oil and gas industry, starting from the exploration and production to the midstream part, where the oil and gas, there is a storage and transportation of the oil and gas. And the last part of this sector is the downstream process, where we have to valorize our crude oil and natural gas in order to obtain some petroleum products or some petrochemical material. So I will focus my talk tonight. I will discuss about the downstream processes mainly. The point number 4, how to obtain petroleum product like light crude, gasoline, diesel, and jet fuel from crude oil, and how to transform natural gas to petrochemical product. So let's start by the composition of crude oil. How to transform this non-valuable product, non-valuable material. Crude oil is a mixture of a lot of molecules, starting from the aliphatic or paraffinic component, which means a linear chain of hydrocarbon, some aromatics components based on benzene rings, as you can see in the figure here, some aromatic components, and some cyclic component called naphthalene. So mainly 98% of elementary basis of crude oil is hydrogen and carbon. However, we have some non-hydrocarbon called non-hydrocarbon product like sulfur component, nitrogen component, oxygen component, and metallic component. Some of them responsible of the deactivation of catalysts in the refinery and will make some pollution after combustion or after the use of crude oil. So as you can see from this introduction, crude oil in this form is non-valuable. I can't use my crude oil in my engine or in my petrochemical industry directly. So I have to treat before going to the end-use product, my crude oil or natural gas. So each crude oil produced in the world has a unique chemical composition, which varies according to the manner of its formation. Currently more than 150 crude grade are traded, and many of these streams are blended from 2 or more fields. So as I said, the crude oil is a complex mixture of hydrocarbon component with small quantities of sulfur, oxygen, nitrogen components called heteroatoms. So carbon and hydrogen make up around 98% of the content of typical crude oil. So what can I do with my crude oil? Two things. First part is the production of fuel as gasoline, diesel, or jet fuel, or called material for the transportation sector. Up to 80% of the product in the refinery are used to the petroleum, to the transportation sector. The other part, the liquids produced in the refinery, are used in the petrochemical plant in order to get some plastics, cosmetics, hydrogen, syngas, and other components. So crude oil, first of all, enters to a refinery. I get product for the transportation sector and another product called feedstocks, or the material or the raw material that should be used in the petrochemical plant in order to get the final product. Now, what is in a barrel of crude oil? Crude oil, 1 barrel equals 42 gallons. So if you use the US refineries, some advanced refineries, we can transform our barrel of crude oil to some valuable products such as gasoline, 20 gallons, distillate or diesel, 12 barrels, jet fuel components, and other products. So the first part of transformation is related to the transportation sector. The other part, like 6 gallons, these products are liquids used in the petrochemical industry to make a variety of chemicals and plastics. So this transformation of crude oil to some valuable products will depend, first of all, on the modernity of the refinery, which means, do I have some advanced equipment like catalytic cracking processes, thermal cracking processes, delayed coking processes, and also depends on the type of crude oil and the percentage of sulfur. Light crude oil, medium crude oil, or heavy crude oil. So this percentage of gallons in a barrel of crude oil may be different based on the type of crude oil and the modernity of the refinery. So the first part, I repeat, how to valorize my crude oil. My crude oil is transformed to all these petrochemical products, plastics, syngas, cosmetics, rubber, etc. The International Energy Agency estimates that more than a third of gains in oil demand by 2030 will come from petrochemicals. The other part of crude oil should be used mainly for the petroleum or the transportation sector, gasoline, diesel, and jet fuel. How can we transform all these non-valuable crude oil to some valuable petrochemical or transportation sector product? By entering to the refinery. So regardless of the source of my crude oil, it can be light, medium, heavy. All crude oils can enter to a refinery in order to obtain all these final products. LPG, liquefied petroleum gas, gasoline, jet fuel, diesel, heavy fuel oil, and others. Some liquids like naphtha obtained in the refinery by a process called catalytic reforming process. Some naphtha are transformed to petrochemical product by steam reforming or steam cracking process, and then will be discussed in the coming slide in this lecture. So in a modern refinery, it's a mixture of different catalytic and non-catalytic processes, some physical and some chemical processes. I mean by physical processes, there is no transformation of the structure of chemical components, like the atmospheric or the vacuum distillation unit, where you separate your component based on their boiling point. However, in the catalytic cracking process, you broke the molecule to transform some heavy molecules to more valuable components like diesel or gasoline. So nowadays, refineries are complex and highly integrated facilities that may contain as many as 15 to 20 process units capable of handling a dozen or more different crudes with capacity up to almost 1 million barrels per day. So all these products, all these petroleum products used for the transportation sector, or the other liquids used for the petrochemical industry, if I take my crude oil as a feedstock, can be treated in the refinery in order to be obtained. So what type of refining operations performed in the refinery? Three different type of operations: the separation processes, the conversion processes, and the treating processes. I mean, by separation processes, I separate my feedstock of crude oil by using the difference of boiling point between the components in order to obtain fractions, and that's why the process is called fractional distillation. Or by conversion, which means I change the structure of my components to get more valuable products by cracking, for example. And finally, the treating processes that should be used in order to remove some impurities like sulfur, metals, nitrogen, oxygen in crude oil or in petroleum fractions. So if you look to the first type of separation processes, crude oil enters to an atmospheric distillation column. Crude oil is heated until 350 degrees C, and I obtain at the output of the distillation column all these fractions like LPG, gasoline, naphtha, kerosene, light gas oil, or diesel. But I will still have some heavy fractions heat at the output at the bottom of the distillation column called residue. These residue can't be separated in the atmospheric distillation. That's why I move to another distillation column where I decrease the pressure in order to get more valuable products, for sure heavier than the product obtained in the atmospheric distillation column, but can be used in some catalytic processes in the refinery in order to obtain more gasoline and diesel, because the quantity of gasoline and diesel obtained through the first distillation column, called straight run naphtha or straight run gasoline, are not enough to, if you want, be used in the engine motors in the world. That's why I need to search another source for gasoline and diesel and jet fuel by cracking processes, by using this heavier component called vacuum gas oil through the vacuum distillation column. So the oil is heated up to 350 to 400 degrees C. Only gases reach the top of the distillation column. Then the liquids are collected on trays here on the distillation column, located at different heights of the column. Each tray collects a different petroleum cat or fraction, and the heavy residual left over after atmospheric distillation column here still contain some medium density product. That's why it's important to enter this second distillation column called vacuum distillation. Now, what about the conversion processes? Okay, I separate my crude oil by using distillation column to some valuable products. However, I can still do some cracking processes in order to have more valuable components by cracking, like catalytic cracking processes, FCC or fluidized catalytic cracking process to get more gasoline, or hydrocracking to get more diesel. Also, I do catalytic reforming in order to obtain some aromatics components to be blended in the gasoline pool in order to increase the octane number, or some cracking processes, thermal cracking processes, in order to obtain petroleum coke that can be used as electrolyte. So one of the most important catalytic cracking process in the refinery is the FCC. Here, as you can see in the previous slide, here you can use these fractions, vacuum gas oil obtained from the vacuum distillation column, as the feedstock in the reactor in this catalytic cracking. After a certain time, you will get the gas, more gasoline, more light cycle oil or heavy cycle oil, so more valuable product through a between brackets non-valuable vacuum gas oil. For sure, with time, the catalyst used, that's why it's called catalytic cracking, the catalyst used will be cooked, a certain layer of carbon will be deposited on the surface of my catalyst and will deactivate my catalyst. That's why there is a certain regenerator where I put my cooked catalyst in the regenerator, a kind of combustion at high temperature to remove coke. That's why you have here the output gas from the regenerator, and you can reuse the catalyst again in the catalytic reactor in order to obtain more and more gasoline or other valuable product. Other catalytic process or non-catalytic process used in the refinery are the thermal cracking process, used at high temperature without catalyst to crack some molecules, or reforming processes in order to change the structure of some molecules refined. Now we move to the last processes used in the refinery. Last category of processes is that treating by hydrodesulfurization processes, which means I remove sulfur that can create some corrosion or cause air pollution, or also can deactivate the catalyst for some catalytic cracking processes, but by a process called hydrodesulfurization, like the feedstock, if it contains more than 1 to 2% of sulfur, enters to this unit. And as you can see in the figure, here you have a sulfur component. You should remove this sulfur in the reactor by adding some hydrogen and catalyst to obtain a pure hydrocarbon. So this hydrocarbon now is pure without sulfur. However, you produce at the same time some H2S gases that should be treated by what we call a close process in order to obtain sulfur solid from this H2S component. So treating involves removing or reducing the corrosive atoms such as sulfur. For diesel, for example, I work at 370 degrees C at high pressure with hydrogen in order to remove sulfur. And gasoline and diesel sold in Europe cannot contain more than 10 ppm of sulfur. So
دكتور وائل سؤال صغير بس هيك على السريع.
Yes.
الهيدروجين سلفايد منه it's a nocive to
yes,
it's very dangerous.
H2S.
They have to add it to have the final product.
Please, can you repeat again?
What I'm saying, in the process of treating,
Yes.
they have to add a certain amount of hydrogen sulfide to it, or they have to remove it?
No, I have to add here some hydrogen, pure hydrogen energy or hydrogen molecule to remove sulfur from this molecule in order to obtain a gas, H2S.
Okay.
But this H2S should be treated as well in order to remove sulfur as solid by what we call a closed process.
I got it.
Okay, perfect. So, I transformed my crude oil by some catalytic process, a non-catalytic process, thermal cracking process, or reforming process to some valuable product. However, I need some specifications. For example, if I use gasoline, يعني gasoline 95 or 98 octane cannot be produced directly through the distillation column in the refinery. That's why I should do some blending, some modifications in order to search for the molecule that resists this what we call detonation in the engine. I need to search some aromatic components, a branched molecule that can't be prepared directly through the distillation column. So that's why I move to some isomerization process, alkylation process, catalytic process, and catalytic reformer in order to obtain this kind of molecules, as you can see here, aromatic, cyclic component, branched component, isomers that can increase the octane number in the gasoline pool. So now I treated my crude oil, I obtained some naphtha or gasoline with low octane number. I move to some other processes like reforming in order to increase the percentages of some specific component in order to have a final high octane number material that can be used directly in the engine. Because if I have a low octane number, يعني عنده the same composition, it's between C5 carbon and C10 to C12 carbons, the same composition, the same number of carbon. However, we don't have the same structure. The structure of the molecules is very important in order to increase the octane number. If I use a low octane number gasoline in the engine, so the engine will eventually be irreversibly damaged. So to avoid this, it's necessary to boost the octane rating number in the refinery to 95 or 98 by some reforming or FCC processes to get the resistant molecule. Okay, I have my petroleum product. What about the petrochemical products? I have to distinguish between petroleum products obtained in the refinery and the petrochemical products. The petrochemical products that can be prepared through some liquids obtained in the refinery. So I take some liquids from the refinery, a fraction from the refinery called naphtha, and I use this naphtha to get some polymers or hydrogen or ammonia used as fertilizer, polyethylene, polypropylene, nylon, polystyrene, PVC, whatever. However, this naphtha can't be used directly through the crude oil. So crude oil, distillation column, naphtha, treatment of naphtha, remove of sulfur, naphtha can be used now as feedstock, as raw material in different processes in the petrochemical industry to get the final product. In addition to naphtha, I have my natural gas. Natural gas can be used. It's a very important source for the petrochemical industry. Methane can be used to produce syngas, hydrogen, and carbon monoxide by what we call steam methane reforming. I add some steam to my methane or my natural gas if the percentage of methane is very high. So natural gas can be used as a feedstock for the steam reforming, or ethane from natural gas can be cracked. I crack my ethane to obtain ethylene. Why it's very important? Because ethylene or all light olefins doesn't exist in crude oil or natural gas. يعني ما عندي light olefins. I don't have light olefins. However, light olefins, ethylene, propylene, butadiene, etc., are very important to get my polymer. So I can't produce polymer, plastic polymer, polyethylene, polypropylene, polybutadiene, etc., without the source. The source is a single monomer called ethylene or propylene. This can be obtained in the petrochemical industry by cracking, by a process called steam cracking. So I change the structure. I crack my ethane or my naphtha, my natural gas from gas, and my naphtha from crude oil. Just distinguish between these two sources of petrochemical products. Naphtha and natural gas can be treated by steam reforming to get carbon monoxide and hydrogen, can be treated by steam cracking to get light olefins later on. Syngas, carbon monoxide and hydrogen can be used to produce methanol, or hydrogen with nitrogen can be used to produce ammonia as fertilizer by a process called Haber process, ethylene to polyethylene, styrene to polystyrene, etc. So these are the major categories in the petrochemical industry: syngas, olefins, and BTX, benzene, toluene, xylene. Because if I get benzene, toluene, and xylene from naphtha, I can do a polymerization to get polyaromatics with some physical and mechanical properties different than the polymers obtained by the light olefins, polyethylene, and polypropylene. So syngas, first category, light olefins, the second one, and BTX, the third one. Feedstock for the petrochemical industry. Why hydrogen? Hydrogen can be used with CO2 to create synthetic fuel. I can also remove my CO2 by this way. I can use nitrogen with hydrogen to get ammonia. Can be used for heating, for hydrogen vehicle, but also the most important use for hydrogen in the oil and gas industry is for the hydroprocessing. As you can, if you remember, when Robert asks me about the H2S, what is the source of my hydrogen in the refinery? How can I obtain hydrogen H2? Hydrogen H2 doesn't exist in nature. ما عندي H2, I have H. So there is two sources. I can do electrolysis of water, for example, to get hydrogen, or by steam reforming of natural gas. Steam reforming of natural gas is used, is the industrial process to get hydrogen that can be used in the refinery for the hydrotreatment or the hydroprocessing to remove sulfur, metals, nitrogen, etc. So this is the first part or the first category of petrochemical product. The second one is the production of light olefins. Why light olefins? Because light olefins, ethylene, propylene, butadiene, manun موجودين in crude oil. There is no light olefins in crude oil. So I need to search a way to get light olefins from naphtha or light gas. Two different sources: naphtha, oil, liquid; light gas, natural gas, steam cracking, high temperature, thermal cracking without catalyst, high temperature, heat recovery, compression, acid remove, and then I move to a cold section. This first part is the hot section where I get my ethylene and propylene and all the other byproducts. I move to cold section where I decrease the temperature to transform these gases into liquids. And then by using a fractional cryogenic distillation, I get again my ethylene, propylene, and other product by separation, by simple separation, because I'm liquid now. So I move from gas in the hot section to liquid by decreasing the temperature, and to transform all my gases to liquid. Then I do separation through a distillation column if you want, and then you get ethylene, propylene. You take ethylene as a pure source to get polyethylene beads, and this polyethylene beads is used to get the final petrochemical product, polyethylenes, such as bottles or something else, or high density polyethylene used in pipeline. What about the mechanism of cracking? Why I should obtain this propylene and ethylene by cracking? You take naphtha or natural gas, whatever you want as source, naphtha or natural gas. You do thermal cracking by a free radical mechanism. You broke the carbon-carbon bond. Here you have a carbon-carbon bond, and here you have hydrogen. So you broke the carbon-carbon bond to create some radicals, one electron here, one electron here. And then after rearrangement of the molecules, you will get in the reactor at the output some ethylene and propylene that can be separated as discussed before. Okay, now what about the Lebanese case? Actually, there is no petrochemical or refining processes in Lebanon. لأنه if you look to Zahrani refinery, the refinery used to operate the capacity of 18,000 barrels per day, which is a very low quantity now, but it was completely shut down in 1989. It used to produce the following product: liquefied petroleum gas, 500 barrels, gasoline, two types of kerosene, gas oil, diesel, and fuel oil. We have some storage tank in the refinery, 2 categories for, or 2 tanks with these capacities for gasoline, for gas oil, 4 tanks, and for fuel oil. Beside these, all the refinery need some maintenance. Some don't have spare parts, some equipments. Also, we cannot operate anymore at 18,000 barrels per day. The storage capacity of the refinery is 150,000 barrels for all product, and for this reason, we are now using the terminal storage facilities, or the facilities for the terminal, and not the facilities of the refinery. The second refinery in Lebanon, also not in activity since 1992. Activity, he started at 40s in 1940 with a capacity of 35,000 barrels per day. Sadly, both refineries now are not used to treat crude oil and to obtain petroleum products. So, if you look to the market in Lebanon, you can see like 55,000 barrels of fuel oil per day, or distillate fuel oil per day, LPG, some natural gas per day, and Lebanon gas demand will reach 90 billion cubic feet by 2020. So we consume a lot of petroleum product, but we don't have the facilities, refineries or petrochemical industry to prepare these petroleum products. Imports in 2013, Lebanon's imports of oil and its derivatives amounted to $5 billion. The Lebanese market imported in 2018 alone like 5,000 metric tons of methanol that can be prepared through hydrogen, and 150 metric tons of ammonia also prepared through hydrogen, equivalent to more than $5 million US. For this reason, we have recently published with my group an optimization study published in International Journal of Hydrogen Energy about how to optimize the Lebanese natural gas to get hydrogen or petrochemical plant by steam reforming process in order to have the needed quantity of hydrogen in Lebanon that can be used in the preparation of petrochemical like ammonia, like methanol, or that can be used in the refinery to treat sulfur metals or other component by hydrodesulfurization process. So we did this very recent paper in Journal of Hydrogen Energy. So if you look to this table, we need like for methanol synthesis, for ammonia, for hydrotreating processes, for hydrodesulfurization, for hydrocracking processes in the refinery, or the first part for the petrochemical industry, we need like 67,000 metric tons per year of hydrogen to answer all these data. So we assume a certain composition of natural gas in Lebanon, like 99 or 98% of methane, and then we move to optimize through Aspen HYSYS software by using different reactor, the reformer, the high temperature shift reaction, low temperature shift reaction, and the absorber to absorb all the impurities before getting hydrogen at the output. So we did this optimization, and finally we get like a yield of 87 instead of 66,000 metric tons per year, a yield of hydrogen production 87,000 metric tons per year that exceed the needed quantity because of the meticulous optimization of the operating parameter and the reduction of energy consumption of about 77.5%. So this paper can be directly applied if we have like production of natural gas in Lebanon, if we decide to move to the transformation of natural gas for the petrochemical industry, so we can use such data in order to design the steam reformer plant and to get hydrogen through our natural gas. So I think I finished for tonight. So just a short conclusion concerning this crude oil and natural gas transformation. Please keep in mind that crude oil is a non-valuable material. I have to treat my crude oil in the refinery, natural gas in a natural gas processing plant. I can't enter with a natural gas to the refinery because I need a liquid form. So crude oil is treated in the refinery to get petroleum products for the transportation sector like diesel, gasoline, jet fuel, lubricant, etc., whatever you want. And other part is used for the petrochemical industry, as well as the natural gas. A part of this natural gas, a very small part of Lebanese natural gas, if you want, can be used later on in the petrochemical industry in order to obtain hydrogen and all the components related to hydrogen like methanol and ammonia, to obtain light olefins, and then the plastic industry, polyethylene, polypropylene, polystyrene, etc., and to get also the aromatic components. Okay, thank you for your attention.
Thank you. عذبناك معنا. Thank you, doctor. Thank you, doctor.
Okay, thank you, Dr. Hamad, for this presentation. It was really insightful, and we hope that our audience got informed with this information. And now we shall proceed for the Q&A session. If anyone has any question, please write them down in the chat or simply unmute.
أنا بس دكتور عندي بدي أبلش هيك على السريع مثل ما قلت لك أول شيء، كيف فينا نحن نطبق بلبنان في حال سيناريو طلع إنه عندنا بس الكمية بحاجة للاستهلاك الداخلي، شو ممكن يكون في عندنا مثلا بلانينج أو رود ماب باختصار أكيد هذا كتير واسع، بس شو الستبس اللي لازم ناخذها؟
صح. هلا حسب الاستيميشنز تقريبا بالنسبه للاويل اللي احنا ما عندنا كثير
اوكي،
يعني عندنا تقريبا 800 مليون برميل.
اوكي،
which is منهم كتار حتى لي شغل ريفاينريز عليهم. سو بالنسبه للزيت ما في كثير زيت. بالنسبه للناتشرال جاز يعني الاستيميشنز بيختلفوا كثير حسب الريفرنسز من 25 تي سي اف تريليون كيوبيك فيت ل 90 ولل 100 وللاكثر sometimes. هلا اذا بدنا نشتغل بالكهرباء بعتقد كمان حسب الريفرنسز والمعلومات 0.12 تي سي اف از انف بير يير حتى نولد الكهرباء. يعني فينا قدونا لكميه بدنا نعمل كالكوليشن لسنوات عديده. The second important thing بالناتشرال جاز طبيعي بتدخل الجيوبوليتيك بالترانسبورتيشن. بدنا نشوف بالبايب لاين، هالبايب لاين يلي داخل فيه اسرائيل وفينا نفوت على هذا البايب لاين او ما فينا، لانه اذا بدنا نعمل بايب لاين اتس امبوسيبل، يعني يا اما بدنا نشارك يا اما وهذا شيء سياسي. ثالث احتمال هو ال ان جي بلانت، الغاز المسيل يلي هو بنعمل بلانت ال ان جي بنحول نربح 600 مره تقريبا بالفوليوم، بنحول الناتشرال جاز لليكويد، وهيدا الليكويد بنصير نورده بالبواخر وهيك ساعتها ما بنفوت بهيدا البايب. اوكي. ورابع احتمال يلي هو البتروكيميكال اندستري يلي هو فعلا كثير مهم، لانه ما بدنا كوانتيتيز عاليه تو اوبتين هيدروجين يلي مثل ما شرحنا في كثير استخدامات للهيدروجين، او فينا نروح للبلاستيك لل any kind of petrochemical product by using our natural gas. هلا بيبقى بعدين القرارات تعرف يعني بالفرنسي بيقولوا اوني مال بلاسيبل بالجغرافيا، يعني جغرافيا نحن حدودنا صعبه فبدي يتاخذ بعين الاعتبار. بعدنا عم نختلف اذا على خط خوف بدنا ناخذ هالمساحه ولا بدنا نرجع نطالب ب 1000 كيلومتر مربع زياده بالمي. بتامل انا شخصيا كحدا بهالدومين صار لي 10 سنين يمكن
نسرع في
بتأملوا انه تكون نقدر نتخطى حاجز البوليتيك لنروح لمحلتين. هذا التمني، وبعدين technically everything is easy.
اوكي
دكتور
Yes.
جو هيد بس
تفضل
كنت انه
روبرت.
بس اذا بنعمل الليكويفيكشن للغاز
نعم.
شو كلفته تقريبا؟
هلا
تقريبا مليار وشوي.
بقبرص بعتقد اللي عملوها مليار تقريبا.
اوكي انه مش هالانفستمنت الكبير يعني.
لا بس هلا الانفستمنت مليار منه سهل.
نو اي نو عم نحكي
البنك الدولي هلا
يعني طاق اندستري نحن. اوكي
اكيد.
alright.
So we have a question here related to the portable refinery. What do you think about it, Dr. Wael?
Please again.
There's someone asking about the portable refinery.
Could it be
Portable
floating?
refinery.
Floating?
Yes.
In what sense يعني شو؟ In terms of quantities, the capacity will be reduced. In terms of equipment, we have to see what, because the refineries are not similar. If you look to the history of the refinery, we start with a single atmospheric distillation column without cracking processes. So it depends what you have to put in this refinery. So it's a general question, I guess.
Okay, another one is regarding the demand on the petrochemical to decrease. Will it decrease with the shift towards the renewables?
Please again. Petrochemical to replace the renewable energy.
Would the demand decrease versus the shift toward the renewables?
Okay, I will ask the question.
We can't produce the petrochemical product through the renewable energy. I need the hydrocarbon.
So there will
Yes,
be
exactly. But does shifting towards renewables will decrease the chance of producing more petrochemicals, although that we need them?
No, it's more related to the demand and to the use, because ما فيك تعيش بدون ما تستخدم البلاستيكس.
Exactly.
So you need plastics.
Renewables will never replace oil and gas.
Not for the coming few years.
Okay. Thank you.
Thank you.
So does anyone have any more questions?
Yes, Doctor.
Yes.
Thank you for your presentation. Very interesting. And I meant to ask you first if you did any assessment in your study on the local demand
of hydrogen.
If you go further in details, the local demand of the Lebanese market and what's actually required specifically from an updated or an upgraded downstream refinery plant in Lebanon. Would the $1 billion, like Robert explained, would be sufficient to fulfill most of the local demand first? And second,
yes, okay.
Go ahead, please.
First, we have to distinguish between the source for petrochemical products. Is it liquid or gas? يعني يلي سألوا روبرت about the LNG plant, I prepare liquid natural gas from natural gas. However, liquids used through the refinery هن جايين من crude oil. So in Lebanon ما عندي كمية, there is no like more than 800 million barrel of crude oil يلي ما بيستاهلوا نعمل حتى rehabilitation للrefineries. Okay, so concerning crude oil, I guess هلا ان شاء الله يطلع غاز بعدين نشوف. Concerning crude oil فينا نحطها على جنب. Concerning natural gas, demand for hydrogen is done in our paper. We are actually working on a second paper concerning the demand of light olefins and plastics. But I don't have the final numbers.
Are you in your study? Are you taking into consideration the 2050 Paris Accord targets and the different pressure that is being put on the 2030 targets and then the 2050 targets, mostly from the Western and advanced world, regarding the global environmental footprint of the petchem products and
yes, for sure, for sure. If you look, if I can go back to this process, for example, here at the end of the process, you can use a kind of absorber or a unit to absorb all some impurities. So the output from this unit is a clean hydrogen gas, like 99.9 pure hydrogen from the process. For sure, you optimize theoretically the process. You optimize theoretically the process by using all the given data, all the given units. بس بعدين in some countries like Lebanon, إذا أنا بيجي بقول له هيدا البروسيس وهو بيقول لي ما بحط ابزوربر وبياخذ لي لضبلجه بتاعتها، يعني ما بعرف، بس أنا لازم أحط absorber، أكيد لازم أحط class process to treat sulfur.
Yeah,
for sure. So I do the optimization, of course, in my studies based on this regulation, أكيد.
So as far as we stand right now, with the prospect of existing bigger potential to have gas rather than crude oil,
yes,
the likelihood for development of a downstream industry based on refineries in Lebanon is somehow weak.
Yes.
Considering the local demand, being a small market, and given the feedstock or the source that we're going to base our refineries on, we don't have much of crude expected to be produced.
Yes.
So the bottom line, most of our production, technically what you're saying, is expected to go toward export.
For crude oil, you mean?
For crude oil or gas?
For crude oil, we don't have this huge quantity. Yes. So
for
oil,
gas, would it have a major application in the refineries?
Sorry, gas ما فيك تقول للgas refinery.
Okay, there you go.
It's a gas processing plant. Okay, so the refinery لازم تفوت crude oil و distillation column is the first unit in the refinery. ما فيك تفوت gas على ال distillation column، بدك تفوت liquid. So gas processing plant فينا نعملها to remove sulfur to get a pure natural gas. بنروح على petrochemical industry، شوف قديش الداتا اللي ما بعرف قديش الرقم بالامبورت للامونيا هيدا البيبر تبعنا والميثانول اتسترا was huge.
So مش بالضروري دكتور للسوق المحلي، يمكن نقدر نكون outsource other markets, other niches.
أو as pure natural gas, yes. As liquefied natural gas, yes. But depends on the initial quantity.
هو المشكلة اللي عندنا إياها بالrefineries mostly بيوروب. You have an overcapacity currently in the current period that we're going through. You have an overcapacity of refineries in the Western world, and also the Gulf was able in the last decade to upgrade the refineries to become like the latest in terms of like big technologies, and they have the big production and the right feedstock. So anyway, this is like a market which is hard to crack, to get into, and then benefit from niche markets and exports. So
for export, yes. Yeah, and what you mean by but the advanced technology in the refineries, it's like you have some equipments or some processes that can be used to more light components. لأنه you can treat your heavy crude oil in these modern refineries to get maximum of gasoline. إذا كانت الريفاينري ما فيها equipment وبتعمل بس only a distillation column or some cracking processes, you will get very low % of light product.
It will not be.
So we are not able, I guess, to create such a modern, well-advanced refinery in Lebanon, especially with this 800 million of barrels.
Okay.
So according to you, the best current option we have once we extract, let's say, the natural resources that we have in the sea in Lebanon is to benefit mostly from export, either through a pipeline.
I can't answer this question because I don't know really the quantity.
Yes,
Okay.
this is one.
Conditional,
Secondly, we can use it mainly, in my opinion,
yes,
power production and
for sure
the export. That's all. Unless we
power production, because it consumes like 0.12 for export if the quantity is really important, and if we think about a petrochemical industry, we can use it for hydrogen production, methanol, ammonia, plastic industry, etc. So we should do the plan of all of this manufacturing.
Okay. All right.
Okay, so we have a question from Pascal. Are there any cleaning processes for the crude oil or natural gas before refining?
The first process in the refinery before entering the distillation column is called desalting process. Desalting, you remove salt and water. Okay, this is the first step, and then the first real unit in the refinery is the distillation column. Concerning the natural gas, because the natural gas is mainly composed of methane, CH4, ethane, C2, propane, C3, some traces of butane and pentane. So very low concentration of impurities, sulfur, nitrogen, oxygen, because we don't have some heavy molecule like asphaltene existing in crude oil. ما عندنا like more than 5 carbons. In crude oil بيكون فيها chain more than 60 carbons بقلب chain وحده. So that's why the processing in terms of impurities in natural gas is easier than crude oil. In terms of impurities, however, it's more complicated because we are dealing with gas compared to liquid in the refinery.
All right.
So thank you again, Dr. Wael, for this presentation. It was really great and
thank you so much.
Beneficial piece of information. And thank you all for attending, of course.
It was really an honor, Doctor.
Thank you, Robert. Thank you so much.
Thank you so much.
See you.
See you, Dr.
And keep posted for next week's event, which will be exciting about and related to the Lebanese experience at SP Adipec University program, which will be presented by Ms. Noor Al-Hariri.
Okay.
Thank you, Thank you, Hassan. Thank you, everyone.
Thank you, Hassan.
يعطيك ألف عافية.
Thank you, everyone.
Thank you, guys.
Good night.
Thank you.
يعطيك العافية.